All right. Okay. Hey guys, welcome to another episode of Professionally Curious. I'm joined today by Sreeram, someone that needs no introduction. I'm the founder of Soon, and we're really glad that we get to partner with Eigen throughout our journey as Soon, become one of the highest performance chains with Eigen DA underneath. So we'll get into all of that. We'll unpack all these details, but maybe we'll start with some introduction, Shrem. Let's start with the interesting beginning of your career in crypto, right? So you gave out a 10-year position at University of Washington for a job in crypto. Why? What caused you to make that switch from academia to crypto?
I think it's two things. One is on the technical side. I think people are talking today about losing their job to AI. I lost my job to AI in 2017. So the story is I was working on genomics and DNA sequencing at that time. And I was working with this physicist who's a very renowned physicist. He won the Breakthrough Prize. He has the fastest measurement of the gravitational constant G. But we were working with him on DNA sequencing. And he has all this physics stuff that he tells us, and we use mathematical models to figure out what the DNA sequence is. And one of my students came to me and he said, you're doing all this complex math. I'm just going to use AI. At that time, it was not even called AI. I'm going to use neural networks to do this better. I said, what kind of a fool's errand is this? Not going to work. But he beat our benchmark in 2 weeks. 2 weeks. I mean, we've been working on this for 1.5 years at that time. And I was like, oh my God, this is crazy. This is can't be true. I mean, I didn't believe it. I gave him other things to do. And sure enough, he can do those things as well. And I developed strong conviction that basically AI and kind of these kind of neural network methods are going to start solving problems, which I was thinking, I got a lot of pride that I'm a kind of mathematician and, can solve these problems. No, just throw a black box and it's going to solve it. It was a shocking kind of realization for me. So that's on the technical side, led me to start thinking about like, what does a world in the presence of super intelligence look like? So this is a very important question. And one of the things I realized is cryptography and blockchains is the one thing that no AI can break, right? It doesn't matter how smart you are, you're not going to be able to break cryptography. You're not going to be able to break consensus and blockchains. So that was one technical reason for me to get interested. But one of my principles at that time was go for big impact. Your podcast here is called Professionally Curious.
Yeah.
And I was basically that, professionally curious. As an academic, that's my job, right? To be curious about new things. But part of what I had done over time is to start thinking about not just curiosity, but impact. So I would say I've shifted from just being curious to impactfully curious. What sorts of things can have impact on? So I started thinking about, okay, it's possible blockchains, and crypto has this role. But I also started realizing that human specialty is coordination. You can build a layer 2 or a blockchain and say, I'm going to build everything. I'm going to build the app. I'm going to build the chain. I'm going to build the consensus. I'm going to build the validators. Instead, we specialize, right? So we build a DA, you build a chain, somebody else builds an app on top of you. Because we specialize and coordinate, we become much more powerful. So coordination is humanity's superpower. And blockchains can accelerate human coordination. So this became, because coordination is bottlenecked by trust, right? I'll work with you if I trust you. I won't work with you if I don't trust you. But if I don't need to trust you and some system assures that everything happens as it should, then many more people can start coordinating with each other without necessarily needing to know and trust the person, because the system has its own mechanism to provide that trust and verifiability. So that became our thesis. That's why I kind of like got into blockchains. And once this thesis got solidified, that technically there's a thing that we are capable of doing, and this field can actually have this asymmetric advantage.
Mm-hmm.
I shifted all over from genomics and AI to
Wow.
blockchains. Sometimes I have a little bit of FOMO. My genomics colleague, last year's Nobel Prize, David Baker from the University of Washington, I was lucky enough to work with him, write a paper on interpreting these machine learning models. So I do have some FOMO at sometimes, but I think the bet is absolutely right that cryptography, blockchains is going to be absolutely crucial in a world with AGI. So it's an 8 year long bet. And when I see people today starting to think about, oh, AI is going to take my job, yes, this is what this happened to me 8 years back.
Right. That's awesome story. It's funny because I actually, when you mentioned the name of the podcast, yeah, I started the whole podcast journey because I wanted to interview the 100 most impactful founders in crypto. So yeah, impact, right? These are all like words that very much resonate with me. But you only learn from people that doing things that are outside of your day to day. I think the best way to learn is to talk to other founders and talk about all the frontier tech. So here we are. You're my number 20, I think, out of the 100 list. And great minds think alike for sure. I wanted to get into this other part of a maybe less unknown fact about you. I think you try to build your own blockchain called Trifecta, right? Which couldn't raise funding. So what made you like? How did that maybe misstep, or I don't even know what you call that, like a
No,
little
yeah,
flop, led you to create a race thinking protocol instead? Yeah.
when we started, so I told you the story. I got into blockchains. Okay, so I got into blockchains. I was not trying to do a startup. We were running the UW Blockchain Research Lab. I just wanted to build the nice protocols and get Bitcoin and Ethereum, whoever, to adopt it. So we don't need, to go do anything on our own. And so first we went to Bitcoin, and Bitcoin guys basically laughed us out, right? Said, hey, it's cool protocols, go do your own thing. We're not changing Bitcoin. And then we went to Ethereum. People were more receptive, but still no change for like many, many years, right? So we realized the only way you can kind of like make impact, the word that I started with, when,
Mm-hmm.
to actually build your own blockchain, because there's no other way to change existing protocols. They have their own history and story and existing people and decentralization. So we said, okay, let's build our own protocol. So this was December 2018, and we started
Mm-hmm.
doing this. And at that time, I'm so far out of like crypto that I don't even know what's a bull market or a bear market.
Right.
I just go and like, hey, it's me and two other professors, and we said, okay, let's go raise money.
Mm-hmm.
I go to different people to try to raise money, and they're all like, they talk to us because we're kind of reputed professors, but nobody wants to write a check. I'm like, what is happening here? I thought this should be easy. And they would ask me, what is the application? Like you're going to have, we would say, oh, we're going to run 100,000 transactions per second and all this stuff. It's like, what is the application? I said, I don't know. If blockchain is a thing, you need scalable blockchain is a better thing, and we're going to do the better thing. And I think what had happened was they had YOLO'd into a bunch of professor coins like the year before.
Oh yeah.
And
Remember
they
what
were,
that-
you
Yeah.
remember that time. And then they were like, you know, Ethereum is 7 transactions, can handle 7 transactions per second, and it's not getting full.
Mm-hmm.
So I don't know what to do with your million transactions per second or whatever you can do. So come back to me. We'll come back to you when we beat the 7 transactions per second demand.
Right.
So that's what happened. But I joke that Trifecta is the most successful failed startup. I mean, it's the
Mm.
most successful failed startup.
Tell
Why do
me
I
more.
say that?
Yeah.
I say that because it was the breeding ground for, there were only 7 people involved with Trifecta. And I think it has at least given rise to 5 or 6 really good crypto startups.
Mm-hmm.
EigenLayer, one of them, right? So I started EigenLayer.
Mm-hmm.
David Shea started Babylon.
Yeah.
Babylon's research paper was something David and I actually co-wrote. And so that became Babylon Bitcoin. He took it up and built a big protocol.
Mm-hmm.
Pramod went and is now a professor at Princeton. He built Witness, which was a protocol on top of Eigen, and then he went off and built Sentient. So he's co-founder for Sentient AI. And Lei Yang was our primary coder. He was,
Yeah.
like, here's my quant, right? So he was our coder, the single coder who wrote, or one of the main coders who wrote Trifecta. And he's the CTO for MegaEth. And then Salman's a professor, is director of machine learning at USC. He has a project called Chain Opera, which is an AI agent protocol. So that's at least six
Wow.
projects.
That's 6 unicorns right there.
That's it. That's crazy. That's a
That is
crazy
crazy.
project. I think what happened was we created an infusion of new kind of thinking into crypto. So we all of these people come from a field called information theory, which tries to study how fast information can be processed, how information can be compressed. And many of these people had built, David Shea, his patent is in every single cell phone. So this is the kind of people. Pramod invented what is now called 4G. Like, so it's really elite in some other totally different field. And like bringing that set of ideas into blockchains was our unique thing.
Yeah. I have so many questions about that. I think I will unpack one by one, but let's start with how did you come up with the risk-taking ideas after Trifecta? What led you to the
So
next?
Trifecta was lots of lessons from Trifecta, right? And the one was, if you're building a blockchain, any product that you're building, you want to be as close as possible to the customer of that product, right? So if you're building a blockchain, who's the main customer? The main customer is actually developers building on top of it. So you need to know what apps they want to build, why they're choosing this framework over some other framework, this platform over some other platform, and know very, very in high resolution how they think. So that was one kind of learning. So start from your customer rather than starting from investors. In
Yeah.
fact, I think if we had gone out and launched Trifecta, it would have been very successful because over time we would have learned all these things. But what we did is we were not indexed correctly on customer first. We were indexed on investor first. But the investors are saying, no, what the hell does an investor know? But they're also like playing a guessing game. But customer, they're real. Like this is somebody who actually wants something to
Yeah.
do with it.
Talking about demand, right?
Yeah,
Demand
it's
side.
talking about demand and generate demand, then all the investors kind of line up. So that's kind of like one of the things that I learned from that. As we moved from like we shut down Trifecta, we moved on. And the other thing I learned from trying to do Trifecta is how hard it is to build a new L1.
Yeah.
Because a new L1 is not simply like, hey, I have a blockchain, you are a developer, just build on top of me. It's a whole ecosystem. You need many sites. You need people to believe that the token is valuable. Otherwise, your L1 is useless because it doesn't have any security. Once it has no security, you're not going to have any developers. And once you don't have any developers, your token goes down even more. I couldn't believe that this is how people are. Still, some people were successful, right? Like Avalanche or whatever, like was actually successful, or Solana at that time was successful in doing it. But it's so hard that we shouldn't expect that the next big idea will be like, the person will be able to solve all these 50 problems. You need to create a new money. You need to create a new like decentralization. You need to create a community. You need to create application. But it seemed like an insanity. I go back to my basic principles. The basic principle is we thrive under specialization. We don't thrive under like you need to do everything. Like that's not a principle. That's not a principle for success. That's a principle for wishing that you're successful.
Right.
That informed like the idea for EigenLayer. The idea for EigenLayer didn't come from staking or restaking. Eigen in German for your own layer. Everybody should build their own layer, specialize, and build something unique, useful, interesting. And these layers all work together. That was kind of like the high level idea. We came up with the name before we had how to do it. We don't know how to do it. We know we want a layer of security that everybody can then build
Security.
on top of. Because that was my problem. I couldn't launch Trifecta because the only way to launch an L1 is to have a successful coin. I didn't even know like what is a coin or a token or anything. I didn't know bull market or bear market. Forget launching a token. So there was no way I could do it, and therefore, like the principle was there are lots of people like this with lots of good ideas, but they can't do all the other like things here. Let's give them a very specific layer which lets them, you have a new idea for a protocol, just throw it onto this platform. It'll find all the decentralized operators, it'll find the stake. You don't need a new token, there's already ETH or whatever other tokens exist. They'll stake and run your thing and make sure it's secure. And then you just need to focus on utility and developers. You
Right.
don't need to do all the other things. Just focus on developers who will use your like service, and then they can build on top. So this was kind of like the pivotal principle for EigenLayer before we had even knew how EigenLayer will solve the security problem using restaking. So we thought we can stake and then like build this up, and then we realized already people are staking for Ethereum. Why not just ask them to stake for more things? That was kind of like the core idea, and that gave rise to like the kind of like the general EigenLayer protocol. But also this brand that you see, like we're rebranded to Eigen Cloud. And I
Right.
think the insights, in fact, the original kind of like inspiration of layers and services all comes from the cloud, right? So if you look at the cloud is actually many, many layers. And inside crypto, I was hearing, oh, there's this concept called modularity, and like, you just build some module. But people thought there are three modules, right? So there's data availability, there's consensus, there's execution, something like that. That's what people thought. But I look at software as a service on the cloud, and I see there are thousands of services. There are 500 unicorn software as a service companies. It's possible because there's the concept of the cloud. So cloud created, like, you don't need to worry about hardware. Somebody will run all the nodes for you. And then you need to worry about the software. But even the software, you don't want to build, an authentication protocol, a payment protocol, and like each one of these for each application, didn't make it a database, a data lake, an inference engine, whatever set of things. You don't want to build all of these things for yourself. Somebody is building these infra as a service, platform as a service, software as a service. Just mix and match them, and then
Right.
you can build very powerful things. And so this was always like our dominating vision. That's why we didn't go from staking, restaking to DeFi, to like
Down that rabbit hole. Yeah.
because
Yeah.
that is what many, many people thought. Like, okay, that's what we don't really like. We didn't come from that. We came from, we want to build the cloud. We want to build the cloud. We want to build the cloud, but of course it should have crypto trust. If I say I'm going to build the cloud, it's centralized, non-verifiable, trust me, bro, what's the point, right? So there's no use.
Right.
So that is kind of like our starting point of.
Yeah. No, I really appreciate that because I think the recent big rebrand and what you guys been focusing on the Eigen Cloud side, it introduces Eigen Verify, Eigen Compute, alongside the existing product lines, right? So all these primitives are working well together to support high performance chains like Soon. So, this is why we originally started talking to you and talking to your team. So I wanted to get into that, right?
Yeah, absolutely.
How does that stack really
Yeah.
help deliver something like what we do right now? We have 30K TPS, 50 milliseconds finality, which is 10 times faster than the OP stack and 8 times faster than Solana. How does the Eigen
Yeah.
specifically enable this level of performance?
Amazing. Let me get into like why we built EigenDA and why we're excited about this working with Zone. So why did we build EigenDA? We built EigenDA because like I said, we wanted cloud scale, but a roll-up's scaling was bottlenecked by DA. So DA is data availability. Data availability means you're guaranteeing that the data is available for anybody to download. Why is this important? This is important because if a rollup makes a claim that, hey, I have executed it correctly, a single node makes a claim that they have executed it correctly, but the data is public and available for anybody to download and check and execute and check, oh, actually, it is correct that this is how execution works. Then they can basically come back and challenge if something went wrong. But imagine like the single node didn't make the data public and just like withheld the data, then nobody can come and challenge it. So this is the role of a DA in ensuring the verifiability of a rollup. So rollup execution becomes verifiable when the evidence is public, that the data is available. And so that is the role of DA. And so when we were thinking about bootstrapping the EigenLayer platform, right, EigenLayer platform needed stake and services. So that's a multi-sided problem. We said we're going to build our first service, which is going to be useful on its own, which is EigenDA, which was actually the core idea behind Trifecta, was to scale data availability. So we took that idea and then said, okay, I failed doing that L1. Now let's just build it as a service, take my own medicine.
Yeah. Stop footing your own tech stack.
Exactly. And just build a DA. And so that was EigenDA. And EigenDA was built to scale infinitely. Like this has always been the wish and scope of EigenDA. And so what does it mean by scale infinitely? If everything is bottlenecked by a single node, then you're only as scalable as a single node. So what we did in EigenDA is no node needs to ever touch all the data. The throughput of EigenDA is not bottlenecked by any one node, it's the sum of all the nodes. That's how much throughput you can get. But if you are not careful with it, what you would do is you would send different data to each node. But if a group of nodes, if like a majority of nodes are not available, then suddenly you lose all the data, which is problematic. What we do in EigenDA is use, erasure codes, KZG, polynomial codes, all the cryptography to make sure the data that you're distributing is in such a way that even 20% of the nodes are enough to recover all the data. So you put in that redundancy. Okay, so that's the core idea of EigenDA, and it can give you high scale without and add the throughput of all the nodes participating in the network, which is very powerful. Okay, so we were building this, and I was initially like, we did this experiment called all chains fit on EigenDA. We crawled all the chains, like including Solana, and then you can just write all the data into EigenDA. So, wow, we have so much throughput on EigenDA. This was when we had 15 megabytes per second. 15 megabytes per second sounds like a small number, and it is small relative to many things happening in the real world, but it turns out to be much higher than the total throughput of all blockchains. This was 1 year back when we did this experiment. Write all the blocks, and it fits on EigenDA. So EigenDA has so much throughput. So it's really nice. But then somebody came and told us, hey, how come EigenDA sucks? I'm like, what do you mean by EigenDA sucks? Oh, it can only do so little throughput. And I said, that makes no sense. Why would you think EigenDA does so little throughput? It's because the execution stack is limited, right?
Yeah.
So think of the data stack and the execution stack. Execution stack is what is doing all the computation, and then you have to write the data. And your speed is limited by the slowest of how fast you can run the
Yeah,
computation.
that's the Trifecta. Yeah,
It's obvious, right? And we
obvious.
are like, oh, other people are building execution. We don't need to build, execution. But you have to reimagine execution when you have infinite throughput on the data. Now, data is not the bottleneck. All the existing Ethereum rollups were hyper fit into Ethereum DA's low throughput. So you have to do a lot of work in compressing the data and like fitting it into the Ethereum DA. So that's what they were all focused on. But suddenly we are like 1000x more than Ethereum on throughput. So you need to reimagine the execution stack. And so that's why we were very excited to partner with Soon, because Solana was also built on like, let's scale this as much as possible.
Yeah.
Like take out just the executions, but it's also an L1, it has all these nodes. In fact, even Solana is limited by full replication. Every node needs to download and propagate all the data. Whereas once you extract it and build an execution stack, like what Soon did, now you can have many instances of this run. Each of them can itself run at very high throughput, but the sum total of these instances can run at even higher throughput. So you have, again, infinite scaling. So that's why we were super excited. And when we saw the kind of numbers that Soon can do, like tens of thousands of transactions per second, bringing it down to like less than 100 millisecond finality, all these things are really exciting for us to do this partnership. So super fast execution combined with super fast data, no bottlenecks in what you can buy.
Yeah, appreciate that. I think the whole idea behind modularizing, each part, the execution part, the DA part, and the entire stack can be optimized to the T, right? So we can truly enable, the new use cases that we couldn't see with the previous stacks. Something, yeah, I want to bring up also is like we did a lot of research, co-research on this, right? Specifically, I think this answers your maybe previous investors' question, like, why do we even need high throughput? Do we even have enough consumption of that, right? And, one thing I think it's pretty clear to a lot of people, like it's not a secret that you're very keen in AI. Have done a lot of research on it, and the two of us, Soon and Eigen, have actually co-authored a piece about purposely built uh, infrastructure for scalable AI. The whole idea is like now we're living in this new future where agentic AI, to your point earlier, it's really replacing human consumption of block data. If we were talking about like, these agents that are consuming data 24/7, they don't need to rest, they don't need to, eat, or they don't need to take a break. And then is the current tech stack even ready for that type of frequency and that type of, high throughput as consumption of data, right? So yeah, so I think it's really, really, really cool to think about that future, how we can build towards that. Yeah, tell us a little bit more about what you're excited about that can specifically fit into that.
Yeah, I think the if you look at it, blockchains are not really made for humans. All about hashes and this hard stuff to deal with these wallets and
Yeah,
private keys and
yeah, yeah,
too
yeah,
complicated for humans. And that's why we saw that a narrow group of super tech nerds could kind of
right.
use these blockchains well. And they say oh, you need to run your own validator, you need to do your own. This is too complicated for most humans to do.
Yeah, it's just like internet, right? When it was first invented, like it took like 10 years for people to really see the impact until the real use case come from like computer talking to computer on internet. It's not like a person talking to a computer, right?
That is a very good, very, very good analogy.
Yeah,
In 93, I think the World Wide Web was invented, which is the graphic user interface
exactly.
into the internet. Otherwise, it's funny. Like you go to 1980s and look at people asking what would be the big application of the internet. And people say, oh, maybe you can use it to send recipes to each other. It's constrained by imagination, right? Because you don't even know what it can be until now there is a website and I can actually put my homepage and I can build a Facebook and I can build a Uber, I can build an Airbnb, I can build an Amazon, and just it goes more and more powerful and abstract on top of it. But I think agents are the user interface for most people are not going to be like today. If you look at what people do, they go and either buy and hodl a coin, they participate in some basic DeFi like lending, whatever, or they participate in trading.
Hmm.
But all of these are just intents that you want to give to an agent. That is a much better UX. Just open your phone and say, hey, I wanna bet on Eigen going up or soon going up, or just watch Joanna's Twitter for alpha and then make a decision. Whatever, right? So whatever idea you have, just feed it to your agent, and your agent should do your actions for you because it's always awake, doesn't get tired, can keep doing transactions. If somebody tries to MEV it, it'll MEV back at it, right? It's not things that you want humans to do. So agents, I think, are a much better UX for most people. Okay, so then how do agents, and obviously another thing with agents is agents can do 1,000, a single agent can do 100 transactions per second. So you don't need to humans can only do so much, and whereas agents can do a lot. And even now big blockchains like Solana's most transactions are bots. That's
Yeah.
just bots written in a narrow sense, and agents are just more intelligent, more powerful. Okay, so when you think about the categories of agents that can use blockchains, you can think of personal agents. This is also you can think of this as broadly. Personal agents are agents that serve a particular user, right? So you can think of this as single player agents. I give an intent, it does something for me, right? So that's a
Hmm.
single player agent. Single player agents can be at the edge of the blockchain. You can run it on your computer. You may put it on your own AWS account or iCloud. May have a agent toolbox, whatever. But there are multiplayer agents. Like imagine Joanna and I enter into a bet and we say this AI agent is going to decide who wins the bet. Okay, so it's a natural language bet. It's think of the future of prediction markets. I speak into it and say, hey, this thing is going to happen. She says, no, that other thing is going to happen. I say, oh, how much are you willing to bet? I'm betting $1,000. That's
Right.
it. Our voice, and then it goes in, and an AI agent will come later and resolve it. Now the question is Joanna going to run the agent, or I'm going to run the agent, or somebody else is going to run the agent? Is it trustworthy if somebody runs the agent? What if Elon Musk changes his mind about left versus right tomorrow morning? What's going to happen to our bet, right, on
Yeah.
who the president is or whatever the thing
How
is?
do we decentralize that? Yeah.
How do you decentralize that? How do you make it verifiable? How do you make it unstoppable? How do you make it not rely on any intermediary party?
Correct.
That's a thing that we've been focused a lot on at Eigen. So on the one side, you need a blockchain infrastructure, which is what Soon is focused on, is like a blockchain infrastructure that can allow high throughput, low latency. IBRL, right?
ERL.
In some sense just take Solana's, goal and
Yeah.
do it better, right? So that's what we're doing.
EVM.
Yeah,
EVM. Yeah.
and just do it better, right? So you can go faster and you can reduce the latency. Because it's single sequencer, you can reduce the latency. Because it uses this modular architecture, it can increase throughput. So it's faster and better. So that's a first part, right? Faster, a chain infrastructure that is going to accommodate it. Now you need a verifiability infrastructure for an agent to be unstoppable and verifiable. And so that is what we're building with Eigen Compute and other things coming up in EigenLayer. Is I want to execute an AI agent. I can't run it. I can have an agent take actions on chain, but I can't put the agent's LLM and other things on chain. Like that's not a thing, right? It doesn't matter you have the fastest blockchain in the world, you still can't do it. Because it needs GPUs, you need a new language, you need like all this stuff, right? So that doesn't run today. And so part of the Eigen Cloud vision is to be able to run agents in an unstoppable, verifiable manner, but bring the results on chain. You're running it off chain, but is as secure as running it on chain. Why? Because you have stake, you have trusted execution environments, you have ZK proofs, you have different kinds of verifiability. And if that node stops running it, you can retrieve the data from EigenDA and somebody else can start running it. So the system runs unstoppably. So EigenCloud is this kind of like the broader umbrella concept that we've built, which is using EigenLayer, it's using EigenDA, but adding more components to it, like compute and AI, so that you can actually execute AI agents unstoppably. And once you have this abstraction that I can just write an AI agent and execute it unstoppably, just like people can trust the EigenLayer smart contract and put $20 billion into it, we can do the same thing with AI agents. These agents become good and better and well vetted and audited. Now people put hundreds of billions of dollars into these agents. So that's really our bet. And so that's where we see the complementarity is a high throughput chain, high throughput stack like Soon can play a role is on the chain side, allowing these agents to do fast, instantaneous, high throughput transactions. On the other side, how do the agents themselves live? Where is the AI code running? Where is the orchestrator running? Where is the memory for these systems? So that's the
Exactly.
complement that we are trying to build with that.
Yeah. Yeah. Definitely super complementary. I guess, yeah, on your end, like what kind of a AI, like now we're talking about mass adoption in a new sense, right? It's like not just to onboard new people, right, into this space, but like how do we onboard more AI agents, right? Interestingly, I've been to your hacker houses. I met all the routes. What are the interesting like use cases that you've seen, and what are the gaps that you see?
I think we are constrained right now by the ambition of crypto builders. So,
Like that's a very pie in the sky kind of answer. It's like
it is because
constrained by your imagination.
it
Yeah.
is. I think really what has happened is when you go back to 2017 and like look at what builders were thinking about We were talking about how do you build a decentralized Uber, how do you build Facebook on chain, how do you disintermediate AWS, how do you build like all these powerful things. And today, like, there's three things people talk about. It's stable coins, it's perps,
Mm-hmm.
lending markets, and maybe like one of the popularized prediction markets. That's it. And so every builder is just doing these four things, and
Mm-hmm.
we are thinking we're going to onboard the world. This is ridiculous. Like these four things, just look at the market size of how many people trade perps in the world. I don't know, like nobody, right? Like no. Do you know any normie that's trading like a perp like instrument, a derivative instrument anywhere? I don't know. It's a small market. It could be large volume, but it's a small market. We are not going to onboard everybody with this kind of like
Yeah.
we need to think much, much bigger. So what happened was people used to think much bigger, but the infra and the UX was not ready in 2017, 2018. So what happened was everybody who used to think about these more ambitious things got selected out because the infra was not ready. And so the only people who were successful is, stable coins, pups, these four things that we're talking about today. I would rate, like, for example, prediction markets is one of the most ambitious things that has actually happened because it was nowhere near obvious that it would be a thing. So Shane and like the guys who stuck it out with prediction markets, actually, like, big kudos to them. But the what I mean by constrained by ambition is suddenly technology is no longer a constraint.
Yeah. Yeah. Now we
With
have the
the high
infra.
throughput chains, with things like EigenCloud, you can run games and bring the results verifiably on chain. So now, like, you can have games with betting markets. Okay, that's a category worth like hundreds of billions of dollars potentially annually. Who's building this? We need to re-trigger the imagination of people to say, you can build this, not just like you can imagine it, you can build this over a hackathon weekend. You can
Yeah.
take a game, put it on top of EigenCloud, slam the token logic on top of a Soon or a chain like that, and then you're good to go. That is a crazy new thing that has just happened. And as it's happening, what we are finding is I give talks which are consistently about build ambitious crypto apps,
Mm-hmm.
build unstoppable AI agents, like just trigger the imagination and ambition of people. Because if you don't have it, you're going to be building the same three things, 100 projects, each of them building the same DeFi perimeters. It's not going to make our market broader.
Mm-hmm.
So that's the constraint limit right now is imagination, ambition. And as a community, if we continue to kind of like, so part of what we have to do, existing builders reimagine what can be built. Like, hey, you had PTSD, you couldn't do this 4 years back because it was not possible. Now you just need to hack together over a weekend. So this is why part of what we are doing is going outside crypto. We were the key
Mm-hmm.
sponsor at Stanford Tree Hacks. We were the main sponsor at Hack MIT. And we want to go outside crypto and tell people verifiability. You can understand what is verifiability. That's what we provide. Unstoppability. That's what we provide. Now you can build like much, much bigger applications on top.
Yeah. Yeah. Super excited about that. I think the fact that you're also just going to the right to the source, right? Going back to academia route and talk to those
Because I
students.
think kids are less constrained by the,
So
yeah,
how
they're just pumped up.
there you go. There you go. Leaving proof of that. Let me end on maybe a throw a curveball, right? Like what is the biggest misconception people have about Eigen?
I think the biggest misconception people have about Eigen is a restaking. And it's just, you need to stake to do something with it. And the something with it is much, much more important than that you're staking, right? On staking, restaking, we're the market leader, $20 billion TVL. Just look at TVL across chains and protocols. It's the number one US protocol in TVL, right? But that's not the interesting part. That's
You're
not
like,
the
it's a
interesting part.
nice problem to have, but I don't want to be remembered for that. So
The
funny.
interesting part is now you can do EigenDA, and EigenDA lets you just remove like throughput limits. Now that you have no throughput limits, you can build like 100 Solanas using the Soon stack and other ambitious stacks like Mega ETH. You can just reimagine what developers can do. And then it doesn't stop with building new chains. You can build things that you can never build on chain like AI agents, like gaming competitions, and bring those results verifiably back on chain. And that's what we want to be remembered for, is triggering the scaling of unstoppable verifiable computation. You can compute anything and then bring those results all back on chain. So that's our kind of like broader goal. And I think we're kind of like narrowly associated. The other misconception, I think, is we had a very hard like period from, let's say, last April, May, when we launched the locked token. The community got like really mad at us. Why are you launching a locked token? My thesis is we're here for 20 years. 6 months or 1 year later is not going to make any difference.
Yeah.
But I think we read the community wrong, that they were excited and they wanted to do something today. Attention is one of those things where you can't take it for granted. You have attention today, and 6 months later, people have moved on, right? So
Right.
that's roughly what happened to us. Is we were at the top of the attention hierarchy in April, May last year. Everybody was looking at us. It was actually, frankly, disorienting for us because we were not prepared to be like at the center of attention or anything. We're building all these developer products. It's going to take years to manifest. And I was like, hey, let's cool it. It's not like let's pour gasoline on our, let's just cool it. Because I think in technology, this happens all the time. People extremely overestimate what can be done in the short term and extremely underestimate what can be done in the long.
Yeah. Yeah.
Right? They're just like, oh, ChatGPT, everything is going to change. No, but no, it's not going to replace all human thing in like many years. But that's the opposite of what happens. ChatGPT is not going to change anything in like a couple of years, but it's going to change a lot in 20 years. And so that's the vision that we have. Is for example, what is my like spicy take on what Eigen's going to enable? I think in 10 years you're going to have fully sovereign agents that are not working for you or me, just their own kind of beings. These agents are going to own trillions of dollars on Eigen Cloud. That's our bet. That's the bet that we're singularly kind of like focused on. All the other things, like if you think about trust and verifiability, which is what I started the story with, right? And we need trust and verifiability, but we also have, as humans, we need trust and verifiability, but we also have alternatives for where we can go get it. We have governments, we have contracts, we have social proof, we have reputation, we have all these things to like establish these trust. Imagine a fully sovereign AI agent, an agent which doesn't belong to you or me. Who's that look out for its interest? Nobody. You can't trust anybody because imagine it gave you its private key to me.
Right.
It's really my private key, no? Like it's just this agent, but it's not this agent's key, it's my key. And I'll just take its money. And nobody may object to it because agents has no rights. So building a framework where it's not just for us humans to trust agents and make them verifiable, it's for an agent to be born, to be sovereign, to create trust for agents to even exist in a sovereign manner, I think needs new infra. And that's really what we're targeting for.
Yeah.
So trust and verifiability for humans to trust agents, but for agents to trust that they have their own sovereign property that they can own and act on top of. So that's what we're building for. That's a really crazy, like what I mean by you underestimate what can be built with this in like a 10.
Yeah. And I think that future is actually sooner than we thought.
That is the crazy thing that we're living through. That future is sooner than we thought. That's absolutely.
Yeah, so we're here for it. And we're working hard towards that future along with Eigen. Really, really, really appreciate this very insightful, very impactful conversation that we had. So I'll have you on another show very soon, I'm sure. Thank you so much, Sreeram.
Thank you so much, Joanna. Privileged to be here. Pleasure to do this chat as well as be a partner for some.
Absolutely, Sreeram. We'll talk soon. Thank you. Ciao.